This is K Anand Goud, Assistant Professor, Civil Engineering Department, Institute of Aeronautical Engineering. In this session, I am going to discuss about the types of concrete, lightweight in types of concrete, again, lightweight concrete, high performance concrete, and polymer concrete. So in the last session, I have discussed about the plain cement concrete, reinforced cement concrete, and fiber reinforced cement concrete, right? So in this session, I am going to discuss about lightweight concrete, high performance concrete, and polymer concrete. So coming to the lightweight concrete. So here, one of the disadvantages of using conventional concrete. So what is the main disadvantage here in the conventional concrete is it is having more weight compared to lightweight concrete. The normal concrete weight is more. So whenever you want to prepare lightweight concretes, like lightweight structures, there if you use normal conventional concrete, the weight of the structure will increase, right? So to decrease that, we are going with the substitute concrete, that is lightweight concrete here. Okay, so one of the disadvantages of conventional concrete is high self-weight. Self-weight is nothing but the weight of the material itself. Okay, that is what the self-weight here. So density of the normal concrete, okay, normal concrete density is around 2200 to 2600 kg per meter cube. That means 1 meter cube of volume. If you take 1 meter cube of volume, then in that particular volume we can place around 2200 kgs to 2600 kg of concrete. So that is a normal concrete density. So here coming to the lightweight concrete density, it is around 300 to 1850 kg per meter cube. Okay, this is almost half of the normal concrete density. So this is why, this is the reason we are going to use lightweight concrete to prepare the lightweight structures, okay, in the constructions. Okay, so basically there is only one method to reduce the weight of the concrete, by inducing the air in the concrete, okay, or else by using the aerated aggregates. So here by using these three methods, okay, by using these three methods we can reduce the weight of the normal concrete. So here the first one is by replacing the usual mineral aggregates by using cellular porous aggregates. Okay, by using normal weight aggregates will be replaced by using porous aggregates. That means porous aggregates are nothing but the aggregates will contain some pores, voids in the inside of the aggregates. Okay, so suppose if this is your aggregate, then here in between this particular aggregate core, so we may have some air spaces. Okay, so by using those aggregates we can reduce the weight of the normal aggregate, normal concrete. Okay, and second method is by introducing gas or air bubbles in mortar. Okay, so while preparing concrete, we are going to mix cement, water and aggregates, right? So whenever you are going to prepare mortar, so in that mortar we are going to induce some air bubbles, okay, by using different chemical admixtures, okay, or else gas. Okay, so by using chemical admixture we are going to induce some air bubbles or gas inside the mortar. Okay, this particular concrete is known as aerated concrete. That means we are going to induce the air into the mortar. Okay, that is why it is called as a aerated concrete. Okay, and next one is by omitting sand fraction. That means whatever the sand we are using, fine aggregate we are using in the concrete, that will not be used for preparation of lightweight concrete. So this type of concrete is called as a no fine concrete. Okay, so this particular type is called as a no fine concrete. So this particular type of concrete is called as a no fine concrete. Okay, so no fine means here fine aggregate is not used in the preparation of concrete. Okay, this is what about the different methods of reducing the weight of the concrete. So coming to the first one, so we have different types of lightweight concretes. So to prepare that particular lightweight aggregate concrete, the first one is lightweight aggregate concrete. So in this particular aggregate concrete, here we are going to use some stones which are having very less weight. Okay, so here first one is pumice. Okay, pumice is the first type of stone which is having very less because of the pores present inside the stone. Okay, so it is used for reinforced concrete roof slab, okay, mainly for industrial roofs in Germany. Okay, so these particular rocks or stones are used mainly in Germany to prepare the roof slabs or else industrial roofs, okay, to reduce the weight of the roofs. Okay, they are going to use these particular stones in place of aggregates. Okay, and next one, foamed slag. Okay, foamed slag is nothing but which is obtained by controlled processing of BFS. That means blast furnace slag, okay, which is obtained by waste material in the manufacturing of metals. Okay, so from there we are getting blast furnace slag, right? So that will be processed again, okay, by compressing, okay, by with the use of water and steam or compressed air, okay, by using water and steam or compressed air, okay, by using these two materials we are going to process the blast furnace slag, and with that we are going to get this type of aggregates. Okay, so the weight of these aggregates is also very less, and these aggregates can be used in the preparation of lightweight concrete. Okay, that is foamed slag aggregates. Okay, and next one, expanded clay and shales. Okay, so next one is expanded clays and shales. Okay, by using this particular clay, okay, red soil or black soil, okay, by applying some air admixtures, okay, by aeration process we are going to prepare these particular aggregates. These are called as expanded clays. Okay, by the induction of air into the clay material we are going to prepare this type of aggregates, and these aggregates are used in the preparation of lightweight concrete. Okay, and next one, sintered pulverized. Okay, so this will be obtained from the fuel ash aggregates. Okay, fuel ash aggregates are nothing but from wood fuel we are getting some ash, right? So that will be pulverized. Okay, that will be subjected to different temperature, high temperatures, and those are made into small round particles. Okay, so these are the aggregates which are made up of by using fuel ash. Okay, that will be pulverized. Okay, sintered pulverized aggregates. Okay, these aggregates also used in the preparation of lightweight concrete. Okay, so next one, aerated concrete. Okay, this is the second type of lightweight concrete, that is aerated concrete. So in this aerated concrete, the lowest density, okay, it will be having the lowest density and thermal conductivity and strength. Okay, the density of the particular aerated concrete is very less, and strength is also somewhat very less compared to other concretes. Okay, so aerated concrete is a lightweight cellular material consisting of cement and lime. Okay, along with cement and lime, it is also having sand and other siliceous materials. Okay, to get this particular aerated concrete we are going to use cement material, or else on other binding materials like lime, okay, or else sand and other siliceous materials. Okay, sand is nothing but silica material, right? So in place of sand we can use other siliceous materials also. Okay, like stone dust also we can use. Okay, crushed stone. From crushed stone also we are getting small particles, small fine particles. Okay, so those materials also we can use in place of sand. Okay, by using these materials they are going to prepare aerated concrete. Okay, next, it is made by either physical or a chemical process during which either air or gas is induced. Okay, so when you prepare this particular aerated concrete, we are going to induce some gas or else some other types of air into the particular slurry of the concrete. Okay, and next, which generally contains no coarse material. Okay, in this particular concrete we are not having any coarse aggregates or else coarse materials. We are using only sand particles or else cement. Okay, cement, sand or else other siliceous materials to prepare the concrete. So here, whenever you are going to prepare this particular aerated concrete, we are going to induce some air, okay, or else some gases into the slurry of the concrete material. So in this particular concrete we are not going to use any coarse material, coarse aggregates. Okay, we are not going to use any coarse aggregates. Okay, so this is one of the examples of aerated concrete. Okay, we can observe this particular cubes or else molds in a construction also. This is aerated concrete which is not having the coarse materials. That means we cannot observe any coarse aggregate, that is concrete. Okay, we are not going to observe here. They have used only sand and binding material, that is cement, to prepare this particular aerated bricks. Okay, this is a lightweight brick which is used in the construction of buildings or other structures. Okay, and next one, it is factory made and available to the user in precast units only. Okay, these particular aerated concrete cubes or else molds or else components will be precasted. That means we are not going to construct these bricks in construction site, but we are going to construct or else we are going to cast these bricks in a godowns or else some other casting godowns. Okay, so there we are going to made these particular bricks or components, and we are going to transport these particular bricks into the construction site. Okay, for construction of floors or roofs or else walls, Okay, and next, blocks for laying in mortar or glue are manufactured without any reinforcement. Okay, so in earlier picture we have seen these blocks, right? Okay, bricks or else these blocks. Okay, these are prepared without using any reinforcement like steel rods or else any fibers. Okay, without using any reinforcement, we are going to prepare this type of aerated concrete bricks. Okay, and next one, no fines concrete. So here no fines concrete is nothing but here we are not going to use fine particles, that is fine aggregate. Okay, in concrete we have cement and aggregates. So in aggregates again we have fine aggregate and coarse aggregate, right? So here we are not going to use this fine aggregate in the concrete preparation, that is no fines concrete. So without using this fine aggregate, we are preparing no fine concrete. So the term no fine concrete generally means concrete composed of cement and coarse aggregate only. Coarse aggregate is nothing but here the size of the coarse aggregate is around 9 to 19 mm. Okay, so we are using aggregates of size 9 to 19 mm and cement. Okay, by using these two materials only, we are preparing no fines concrete. So no fines concrete is mainly used for load bearing. Okay, load bearing structures or else cast into external and internal walls. Okay, whenever you are going to cast the walls at the site, there we are going to use this no fines concrete. Okay, and non-load bearing walls and other floor filling or solid ground floors. Okay, so these are the different applications of no fines concrete. So we can use this no fines concrete in load bearing structures or else cast into external and internal walls or else load bearing, non-load bearing walls or else floor filling or else solid ground materials. Okay, for these all all application we are going to use this no fines concrete. Okay, this is about your different types of lightweight concrete. Okay, so coming to the uses of lightweight concrete. So where we can use and what is the purpose of using this particular lightweight concrete. So here first one is screeds and walls where the timber has to be attached by nailing. So whenever you want to apply cladding like timber cladding, okay, when you want to use timber cladding on the walls, then we can use this particular lightweight concrete for nailing purpose. Okay, if you use solid concrete, okay, normal heavyweight concrete, then the nailing will not be done properly. That much easily we cannot nail the claddings, right? So for that purpose, we are going to use this lightweight concrete so that we are going to have some pores inside the concrete, so that they can take the nails properly. Okay, and then casting structural steel to protect it against fire and corrosion as a covering floor. Okay, so here for casting structural steel also we are going to use this particular lightweight concrete. Okay, so to avoid the corrosion. Okay, these particular steel structures will be protected from the corrosion, right? So there also we can use this lightweight concrete. Okay, and next, heat insulation on roofs. Okay, whenever you want to avoid the heat transfer from the outside surface to inside, there also we can use this particular lightweight concrete. Okay, and next one, insulating water pipes. Okay, to insulate the water pipes. Okay, from water pipes we may get the water leakage, right? So to avoid that also we can use this particular lightweight concretes. Okay, and next, construction of partition walls and panel walls in frame structures. Okay, whenever you are having this type of framed structures, so there we can use these particular lightweight concrete. Okay, these partition walls and panel walls, okay, which are constructed after constructing the whole entire structure, right? So there we can use this particular lightweight concrete panel walls or else partition walls. Okay, and next, fixing bricks to receive nails from the joinery. Okay, or else principally in domestic or domestic type construction. So in domestic construction we are going to use or we are going to join different types of components. So to join these two components we are going to nail it, right? So to take that nails very easily, there we can use these particular lightweight concretes. Okay, so these are the different types of uses of lightweight concrete. Okay, and coming to the high performance concrete here. So high performance concrete is nothing but it is a concrete which meets special performance. That means we are going to improve some properties, okay, specifically. So for normal concrete we are going to follow the basic properties. So along with those basic properties, if you want to increase any property specifically depending upon the environment conditions, okay, or else depending upon the load application. So in all environment conditions, we don't need to improve the all properties, okay. We may just have to improve the special purposes, right? So there we can use this particular high performance concrete, okay. So placement and compaction without segregation. So here one of the property is in this particular high performance concrete is placement and compaction without segregation. So this particular concrete is going to placed or else compacted without any segregation. That means without separation of that ingredient materials, okay. In concrete, cement and aggregates will be there, right? So when you do the compaction, okay, when you place the concrete in the mold or in the placement, there the concrete may get separated, the materials may get separated. So this particular high performance concrete will not get separated, okay. We are not going to get the segregation in this particular high performance concrete, okay. That is one of the major benefits of this particular high performance concrete, that is HPC, okay. And next, long term mechanical properties. Here mechanical properties are nothing but whenever you are going to apply any force on the member, so after applying the force on the member, it is going to behave some differently, like it may get deflection, okay, it may get some cracks inside the member, right? So these all properties, this behavior after application of loads are called as a mechanical behavior or else mechanical properties. So here in this particular high performance concrete, the mechanical properties are going to improve. Okay, that means long-term mechanical properties, the properties are not going to affect, okay, the service of this particular concrete will be very high, okay. And next, high early age strength, okay. By using this particular high performance strength, the early age strength, that means after casting the concrete member, okay, within 1 day or else within 3 days, the development of strength will be high in early days, okay. Normally we are going to check the strength at 3 days, 7 days and 28 days, right? So this development of strength will be increases with increase in time, okay. At 3 days of time, the strength will be different, and at 7 days the strength will be different, and at 28 days the strength will be different. That means depending upon when you move that, with the time, the strength is also increasing, right? So here this particular early days, so that means 3 days, 7 days strength will be very high when you compare with the other types of normal conventional concretes, okay. And next one, durability service life, okay. So here the durability means service life is more than 75 years, okay, in severe environments, okay. If you use this particular high performance concrete in severe environments, okay, the service of this particular concrete will be more than 75 years, okay. That is the durability, that is the service life will be more when you compare with the conventional concrete, okay. And flowability, that means when you place the concrete, it is going to flow continuously into all the corners of the molds, okay. So whenever you are going to have this type of molds, so when you pour the concrete inside this mold, so it is going to flow to all the corners, okay, without any compaction, okay, without any vibrations, without any compaction, the flow will be more, okay. The flow will be good for this type of concretes, okay. And next, self-leveling capability, that means compaction, okay. It is going to compact or it is going to level the surfaces without any compaction, okay. By its own weight, by its own flow, it is going to level, okay. And next, low heat of hydration, okay. The heat of hydration is also very, very less. That means heat generation from the concrete, okay. It is going to generate less heat, okay. Whenever you are going to add water into the cement, it is going to generate some heat, right? So that heat evolution is also less in this type of high performance concrete, okay. So next, the materials required for this particular high performance concrete are cement, okay. We are going to use, this is a normal material. And next, cementitious materials may exceed 25%, okay. So along with cement, okay, we have other types of materials which are having the properties of cement, okay. That is why we are calling it as a cementitious materials, okay. These materials also we are going to use in this particular high performance concrete. So what is the composition, how much, until what point we can use these cementitious materials along with cement, okay. So that percentage may exceed 25%, okay. We can use more than 25% also, but on an average we are going to use around 25 to 40%, okay. So here coming to the examples of cementitious materials, fly ash. Okay, fly ash is one of the examples, and silica fume and blast furnace slag. Okay, these three are the cementitious material. That means these are having the properties of cement, same as cement, because the composition of cement and this fly ash and silica fume is almost same. The proportions may change, but the chemical composition is same. Okay. And next, coming to the silica fume, it contributes to strength and durability. Okay, if you use silica fume in the high performance concrete to prepare the concrete, then due to that silica fume, the strength will be increased and ultimately the durability. That means the service life is also increased. Okay, and next, fly ash and slag cement. Okay, fly ash and slag cement is also used in the high performance concrete. So if you use this particular fly ash and slag cement, there, what is the benefit? So if you use this particular fly ash, the finishing will be better. Okay, that means because of the fineness of the fly ash. Okay, when you compare with the cement fineness, okay, the fineness of the cement particles and fly ash particles. Okay, fly ash particles are very fine compared to cement, so that is why the finishing will be good or else better than the cement particles. Okay, cement finishing. And next, decreased permeability. Okay, if you use fly ash, because of this particular fineness of the fly ash particles, it is not going to allow any voids, air voids. Okay, so if you have very less air voids, then the permeability also very less. Okay, that is the one of the other advantages of using fly ash. Okay, the permeability, that means permeability is nothing but here it is not going to allow the penetration of water, okay, or else any other chemicals. Okay, next, increased resistance to chemical attack. Okay, this fly ash or else slag cement is going to resist the chemicals. Okay, because this fly ash is already obtained from the burning high temperatures, so that is why it is going to resist this chemical attack also. Okay, and next one, slag cement also improves the workability and placement. Okay, because of this particular slag cement, it is also going to improve the workability. Workability is nothing but the proper mixing, proper placing, or else proper transportation without any failures. Okay, without any segregation. Okay, without applying any external forces, the mixing process will be done very easily, or else the placing will be done without any segregation. Okay, and the transportation will be done without any segregation. Okay, so that is what the workability means. Okay, this is what these are the different materials, and along with these cementitious materials and cement, we are going to use coarse aggregate. Okay, coarse aggregate is used around 35 to 75 percentage. Okay, this is the coarse aggregate percentage in high performance concrete, and this particular coarse aggregate is going to improve the hardened properties. That means after getting into hardened state, we are going to check the compressive strength or else tensile strength, flexural strength, right? So these properties are going to improve, okay, in the high performance concrete. Okay, and next, water absorption percentage will be 1.5 percentage, which is desirable in the any concrete. Okay, the water absorption percentage for this type of concrete is very less, and that is 1.5 percentage for these coarse aggregates. Okay, this is the desirable percentage of water absorption we can use in the construction. Okay, and next one, chemical admixtures. Okay, so along with normal materials, we are going to use some extra material, that is nothing but chemical admixture. So what is the purpose of this particular chemical admixture? Okay, these admixtures are used for improving the properties, some special properties. Like suppose here, one of the chemical admixture is high range water reducers. That means here, instead of water, okay, if you add more water, that will be affecting the ultimately that is going to affect the strength of the concrete, because this water will be evaporated during the high temperatures. So, okay, if the water is evaporated, it is going to make, or else it is going to form some voids inside the concrete. So if you have more voids inside the concrete, that is going to affect the strength of the concrete. So that is why we are going to reduce the water content in the high performance concrete, okay, to improve the strength. So if you want to reduce the water content, there we have to use some substitute material. So there we are going to use these chemical admixtures. In that chemical admixtures, again, we are using high range water reducers. Okay, that means here we are reducing the water and we are using some other chemicals. It may be in liquid form, it may be in a solid form. Okay, and next one is retarders. Okay, to make the concrete set very slowly. That means the hydration process will be slow if you add this particular retarders. Okay, so earlier we are going to use high range water reducers. Here retarders are nothing but these are going to slow down the process of hydration, because in some places, in some construction, we need some extra time to place the concrete in a site or else in a particular mold. So there we are going to use these retarders. Okay, these are the some of the examples for chemical admixtures. Okay, so basically the function of the chemical admixtures is to improve the properties, whatever the property, like water absorption property, or else strength property. Okay, or else to slow down the hydration process. Okay, or else to decrease the shrinkage of the concrete. Okay, so like this, depending upon the environment, or else to increase the resistance to chemical attack. Okay, or else to increase the resistance to freezing and thawing effect. Okay, so like this, depending upon the environment, we are going to use different chemical admixtures that will be improving the performance of the concrete ultimately, and this is called as a high performance concrete. Okay, and next, in high performance concrete, the water cement ratio is around 0.4 or less. Okay, we are going to use less than 0.4 or at least 0.4 percentage of water cement ratio. So because of this, the the performance of the concrete will be improved. Okay, indirectly. And next, change of materials is very, very important. So whenever you are going to use the high performance concrete, so here to improve the properties, we are going to change the materials, like depending upon the environment, what is the suitable material. Okay, so depending upon the environment, we are going to change the material proportions, and we are using in the construction. Okay, next, coming to the water cement ratio, the ratio between the weight of water. Okay, what do you mean by water cement ratio? So it is the weight of water to the weight of the cement. Okay, suppose if you have 1:5:10 mixed proportions, so there if you use 1 kg of cement paste, okay, cement powder, so there how much water we have to use? So that will be calculated by using this formula. Suppose water cement ratio is 0.4 percentage, then there we can, here we know the cement content, right? So here cement content is 1 kg, that means 1000 grams, right? So if you do this calculation, you are going to get one value. Okay, that particular value will be your water content. Okay, that X value will be your water content. Okay, ultimately, so the water cement ratio is nothing but here it is a weight of the water to, okay, weight of the water to weight of the cement. Okay, that is what the water cement ratio, which is used in the concrete mix. Okay, so normally what is the water cement ratio we are going to take? Okay, it is around 0.4 to 0.6. That is as per IS Indian Standard Code Book 10262/2009 for nominal mix of the concrete. That is, nominal mix is nothing but, earlier we have discussed about different grades, right? That is M10, M15, M25. So for this type of concretes, we are going to use this particular water cement ratio. Okay, that is 0.4 to 0.6 water cement ratio. Okay, and here in this table you can observe the different water cement ratios for different environment conditions. Suppose if you have mild exposure of concrete to the different environment, there the minimum cement content is 220, and there the water cement ratio is 0.6 percentage. Okay, so when you have mild exposure of concrete, then there we have to use 220 kg per meter cube. That means for 1 meter cube of concrete, we have to take 220 kgs of cement weight. Okay, and for that cement, we are going to take 0.6 water cement ratio. So like that, different exposures like moderate, severe, and very severe and extreme environmental conditions, there we have different types of cement weights, and we have different types of water cement ratios also. If the exposure conditions are very high, very severe, then the water cement ratio is very less, because if you have more high temperature areas, then if you use more water cement ratio, then the water will be evaporated, and in that particular water space, the air voids will be forming. So if you get these particular air voids, then it is going to affect the strength of the concrete. So like that, we are going to get the failures of concrete depending upon the moisture content also. So that is why, depending upon the environment, like mild, moderate, severe, extreme weather conditions, we have different proportions of cement weights and different water cement ratios. Okay, so this is about water cement ratio. And next, coming to the polymer concrete. So here polymer concrete is nothing but it is made up of polymer cement concrete is a composite concrete that consists of synthetic polymers within the binding material. So here we are going to use some polymers. It may be natural or synthetic polymers. Okay, by using those polymers, we are going to prepare concrete material. So here we have different types of polymers. What are the polymers we are going to discuss now? So first one is natural polymers. That means we are getting these particular polymers naturally without any processing. Okay, without adding any other materials into this particular concrete. Okay, these are naturally available polymers. Okay, and these are also called as biopolymers. Okay, so here these particular natural polymers include silk. Okay, silk we are getting naturally. Okay, and rubber. Okay, and cellulose material, wool and amber, keratin, collagen and starch and DNA and shellac. Okay, so these are some of the naturally available polymers which we can use in the construction or else to prepare the concrete material. Okay, and next, coming to the synthetic polymers, it means by preparing or else by processing with the other raw materials, we are going to get these polymers. Okay, so these polymers are prepared by chemical reaction. Okay, by chemical reaction we are getting this type of polymers, and often in the lab also we can prepare this particular synthetic polymers. Examples of this particular synthetic polymers are PVC, polyvinyl chloride polymers. Okay, so you have already gone through this particular materials in the previous subject. Okay, and next, polystyrene and synthetic rubber. Okay, we are going to manufacture rubber also, like silicone, polyethylene and neoprene and nylon. Okay, so these are some of the synthetic polymers which we are going to use in the preparation of polymer concrete. Okay, so this is the microstructure of the polymers. Okay, you can observe the polymer structure here. Okay, and next, coming to the types of polymer concrete. So here polymer concretes are different types. We have 4 types of concretes. So first one is polymer impregnated concrete. Okay, so here in the first type of concrete, we are going to induce or else we are going to impregnate the polymers into the concrete. Okay, that is first type. And next one, polymer cement concrete. So in the particular cement concrete, we are going to use polymers. That means while mixing the cement concrete materials, raw materials only, we are going to add this particular polymers. Okay, and next, polymer concrete. Okay, this is the third type of concrete. And next, partially impregnated and surface coated polymer concrete. Okay, so these are the 4 types of concrete. Now I am going to discuss about each and every type of concrete. Okay, so coming to the polymer impregnated concrete. Okay, PIC. So this concrete is first cured and dried in oven. Okay, after casting the normal concrete. Okay, after casting normal concrete, we are going with the curing period, and then we are going to dry this particular concrete in an oven. Okay, normally normal concrete cubes are dried in a normal atmosphere. Okay, but this particular concrete is dried in oven, and after drying with the dry electric heating or else normal oven, then we are going to induce or else we are going to diffuse the monomers of polymers. Okay, we are going to diffuse the monomers into the concrete material by heating or chemical reaction. Okay, this particular chemicals monomers of polymers are going to induced or diffused into the concrete material by heating these monomers. Okay, so when you heat these monomers, it is going to melt and it is going to diffuse into the concrete. Okay, so mainly the following types of monomers are used. Okay, so what are the monomers we are going to use to prepare polymer impregnated? So here the main point we have to remember is after casting normal concrete. So after casting normal concrete, we are going to dry this particular concrete in oven or else electric method. Okay, after heating this, after drying this particular component, now we are going to induce or else diffuse the monomers by heating. Okay, that monomers are heated and they are going to diffuse into the concrete. Okay, so like this we are going to prepare polymer impregnated concrete. Okay, so now coming to the examples of monomers. First one is methyl methacrylate. Okay, methyl methacrylate. This is one of the examples of monomers. And next, styrene. Okay, this is also one of the monomers. And next, acrylonitrile. Okay, acrylonitrile. Okay, this is one of the monomers. And next, t-butyl styrene. Okay, this is third one. And next, other thermoplastic monomers. Okay, so these all are the different types of monomers which we can use in the preparation of polymer impregnated concrete. Okay, and next one, coming to the next point, the amount of monomer that can be loaded into the concrete specimen is limited by the amount of water we are going to add, or else the amount of air that has occupied the total void space. Okay, so now before going to impregnate or else diffuse the monomer content, so how much content we have to use, that will be based upon the water content that we are going to use in the concrete, or else the air content which is present in the concrete. Okay, based upon those two contents we are going to fix, or else we are going to define the weight of the monomers. Okay, and next, coming to the next type of concrete, polymer cement concrete. So here it will be polymer cement concrete is made by mixing cement aggregates and water and monomers. So while mixing the raw materials only, we are going to add the monomers. It may be liquid form, it may be solid form. Okay, so while mixing these raw materials only, we are going to add these monomers. That is why it is called as a polymer cement concrete. Okay, and such plastic mixture is cast in molds, cured, dried, and polymerized. That means we are going to apply some heat. Okay, after casting and after drying the cubes, we are going to do the polymerization that will be done with the help of heating. Okay, so this is polymer cement concrete. And coming to the examples, okay, different types of monomers which is used in the polymer cement concrete. Okay, here first one is polyester styrene. Okay, polyester styrene, that is one of the monomers which is used in the polyester cement concrete. Okay, and next one, epoxy styrene. Okay, epoxy styrene is also one of the second types of monomers. And next, furans and vinylidene chloride. Okay, so these are the four types of polymers or else monomers. Okay, monomers which are used in the polymer cement concrete. Okay, don't confuse these particular monomers between the polymer impregnated concrete and polymer cement concrete. Okay, and next one, polymer concrete. So this polymer concrete is an aggregate bound with the polymer binder instead of Portland cement. So here, instead of using the cement as a binding material, they are going to use polymer binders. Okay, that is why it is called as a polymer concrete directly. Okay, so next, coming to the fourth type, partially impregnated concrete. Okay, partially impregnated surface coated concrete. That means here, after casting the concrete, that means, so it is produced by initially soaking the dried specimen in a liquid monomer like methyl methacrylate, then sealing them by keeping them under hot water. So here what we are doing, after casting the normal concrete, we are going to soak this particular concrete in a monomer liquid. Okay, so when you soak this particular concrete, it is going to induce into the material, concrete material, and it is going to then after soaking the concrete material, then we are going to seal this particular concrete material by keeping them under hot water at 70 degrees Celsius to minimize the loss of due to evaporation. So why we are going to seal this particular monomers concrete components? Because to avoid the escape of monomers from the concrete material, we are going to seal this particular concrete in the hot water. Okay, so this is what your partially impregnated or surface coated concrete, because after casting the concrete, we are going to soak. Okay, we are going to soak. Okay, we are not going to do any chemical reaction. We are not going to diffuse by heating. Okay, so we are going to soak that particular concrete in the monomer liquid. Okay, from that we are getting this polymer partially impregnated concrete or surface coated concrete. Okay, so this polymerization can be done by adding 3% by weight of benzyl peroxide to the monomer as a catalyst. Okay, so while doing polymerization, here we are going to add 3%. Okay, by 3% by weight of the benzyl peroxide to the monomer. Okay, so in that monomer content, we are going to add benzyl peroxide in the concrete. Okay, for soaking material. right? So now coming to the applications, okay? So coming to the applications where we are going to use this polymer concrete. The first one is majorly we are going to use prefabricated structural elements, okay? That is the major application. So coming to the first application, second application, pre-stressed concrete. So in pre-stressed concrete also we are going to use polymer concretes, okay? And next, marine works, okay? Marine works, to avoid the reaction with the water, saline water, marine water, we are going to use these particular polymers, okay? And next, desalination plants, okay? Whenever you are going to do desalination process, there also we are going to use polymers, okay? And next, nuclear power plants, okay? In nuclear power plants also, to get the resistance from the high heat conditions or else high chemicals, there also for sealing the surfaces, okay, for protecting the surfaces, they are going to use these polymer based materials, that is nuclear power plants, okay? And next one, sewage works, okay, like pipes and disposal works, okay? In sewage works also they are going to use polymer based concrete pipes, okay? Because if you use this polymer based concretes, then the reaction with the chemicals will be avoided, okay? So that is the main reason to use the polymer based concrete in the sewage works, okay? And next, for waterproofing of structures, okay, whenever you want to avoid the leakage of water or else any chemicals, okay, there also we can use this particular polymer based concretes, okay? And next, industrial applications. So majorly we are going to use this polymer based concretes in the industrial application, like to cover the surfaces, okay, or else to avoid the reaction with other chemicals. So we are going to use this particular polymer based materials, okay, polymer based concretes, okay? So this is about your different types of concrete. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.